All right, so for everyone's information, this session is going to be recorded, so we will send it out using the emails that we have from the registration. And let me go to the next slide here. If you're having any troubles connecting, I'm going to put the phone numbers up here for US and Canada that you can call in with the access code. So I'll give you a few minutes to write that down here. A few seconds. I know you guys can write pretty fast. At the bottom, you see the chat box. Now, everyone should see that chat box for questions on their GoToWebinar panel. That's what we're going to use for questions, and we're going to collect all those and answer them at the end of the session, just to keep things running fluidly. And if you're having trouble with audio, you may want to try calling in to the phone number. So this is Scott Diaz with FARO 3D Software, broadcasting from the Houston office here. And first thing, I'm just going to give you a little background as we get started and give you a little history of FARO. You can see FARO started back from its humble beginnings in 1982. And moving all the way up to where they acquired a number of different companies, including here, what's most interesting for folks, 2005 IQ Evolution, where we acquired the laser scanning technology. And then for many of you may be aware now, in just this past March 2015, FARO acquired Qubit, which is where most of these software ideas are stemming from now. So quite a long history, and you know, the former Qubit team's excited to be a part of it. And so, to give you a little background, you know, Qubit is now FARO. Our main former Qubit office was in Dresden, Germany, so it's still there. That was founded in '99 by Matthias and Oliver, and then the office in Houston was founded by me in 2008. Roughly about 29 employees total, and now happily a part of the FARO team globally. And so what you're going to see now is the Qubit name transition to what's called FARO 3D software. So when you see FARO 3D software, you can think, oh yeah, that was the old Qubit guys. And what we do is AutoCAD and Revit based plugin solutions, as well as standalone software for various industries, technology fields. Our classic slogan was always from real world to CAD. And you know, we like to think that our software products stand for accuracy and efficiency. And today, to get into the main part of this demonstration, we're going to be presenting our new PointSense for Revit product, which we're excited. We finally have a PointSense sitting directly in the Revit environment, and Jorg Braun's product manager is going to take us through. He'll do a much better job than I would. So Jorg, I'm going to turn the screen over to you now and let you get started.
Okay, thank you, Scott, for the nice introduction. Hello, everybody. Here from Germany, and good morning for you and good afternoon for me. So today I want to give you a short introduction into the new PointSense for Revit product. First of all, let's have a look to the integration into the FARO workflow from the hardware to the software, where you can find FARO 3D software, so formerly Qubit software. First of all, of course, you have the hardware side on the left bottom, the capturing devices, the Focus 3D, as well as the new freestyle hand laser scanner. And with the captured point cloud data, then you go into the processing and preparing process done with FARO Scene software. And here you can go to the Scene Web Share cloud service for collaboration and sharing your scan data. And of course, you go into the information extraction, and this is done now with FARO 3D software. So you have, the PointSense for AutoCAD products with the plant, building, and heritage inside AutoCAD, and now we have the new product PointSense for Revit, which is directly inside Revit. Next to these plug-in solutions, we already offer Virtuosurf as a standalone product. This software provides several links into other CAD packages, AutoCAD, RigCAD, as well as with generic window link to send into any other Windows software. But today, let's talk a little bit more about PointSense for Revit and Revit itself. First of all, let's have a look what can Revit do with laser scan data. Of course, you can import recap data from RCP and RCS. So recap is the Autodesk laser scan format. Revit itself can import raw scan formats and convert it into recap files, and you can also use the recap software to create the point clouds to use in the Autodesk software, and so also inside Revit. If you have the point cloud in Revit, you have various options for coloring the point cloud, RGB, single color intensity, and you have a few dependent visualizations. So this is a little bit different to AutoCAD. So in Revit, you can change the visualization of the point cloud in each Revit view, in the 3D view, as well as in the plan view and section or elevation views. And you can use the 3D section box and also the view ranges to crop the point cloud, like you can also crop the view of your model inside Revit. And Revit provides also a simple point and planar snapping to the point cloud. This snapping works only on the active workplane, so we have no real 3D point snap. So modeling with Revit vanilla tools is always a manual process, so you can use the point cloud as a reference. You can use the point snapping. You have a pretty good visualization of the point cloud, but if you want to model some elements, you have to do this manually. So this is what can Revit not do with laser scans. So as I mentioned before, we have no real 3D point snapping. So the snapping works only to the active workplane. So you cannot use this in a 3D environment and snap directly to the point cloud. We have no scan view available. I guess you already know the real views or the panoramic views from scene or from recap, and some of you also know our Virtuosurf software that provides this photo-like scan views. In the scan views, you have a pretty good navigation, and it's often more intuitive than the big point cloud. And so this is a nice feature, or would be a nice feature, if you can use such views for modeling process. We have no point cloud support in the family editor. So if you are working with all buildings, with point clouds from all buildings, you often need to create your own building components and the family editor. But with Revit, you have no possibilities to bring laser scan data into the family editor. But this is necessary if we want to create new building components. And you have no automatic object recognition. The modeling in Revit is always a manual process. And all these points come together, and so this was our starting point to develop a product inside Revit to work directly with the point cloud and to find solutions for all these things that Revit cannot do with the point cloud. So at the end, PointSense for Revit is a product that works inside Revit and that extends the Revit point cloud features to give you easy, precise, and fast tools for model creation from point clouds. Let's have a look to the workflow from modeling with point clouds in Revit. Of course, you have to insert the point cloud and adjust your project coordinates. Then you define your levels for each building story and a slice of the point cloud in vertical section. In each level, you can start modeling over geometry, outside walls, interior walls, as well as columns and other elements. Then you have to adjust your families from your libraries to adapt the existing conditions, and you have to create new families in the family editor. And of course, you have to insert and you have to place family instances in the point cloud. And what are the advantages of a product like PointSense for Revit? We can acquire coordinates for your shared coordinate system directly from point cloud. We have wall fitting and wall alignment tools. We have tools to fit work planes, and we have tools to create construction guides. We have we are supporting the family editor with point cloud regions and scan views and author images. And we have a 3D point snap, a real 3D point snap to work in the point cloud to place family objects. And all of these things I want to show you a little bit more in detail in the next minutes. Let's start with the wall fitting. So the wall fitting tool allows you to quickly create precise walls in your level view, in your floor plan view. And this tool also creates new wall types with the wall thickness found in the point cloud. If you have created some of the walls for a whole floor plan or the whole building or several stories, then you will get something like this here in the sketch. So you have a precise shape and a precise position of each wall. This is the best fit position there. And so you won't get 90-degree angles, you won't get continuous wall faces here, and you won't get connected walls. But for a good BIM model, you need such things. You want to have orthogonal wall axes, a minimum number of different wall types, as well as continuous wall faces. And so we provide a tool that creates something like this: 90-degree angles, as well as continuous wall faces and well-connected walls at each corner. But always in a user-defined tolerance. So the user defines in which tolerance he wants to model these things to get the requirements of the Revit system. Let's have a demo about these tools. Okay, here in Revit you can see some walls from a building from the first and second floor. We can also turn on and off the point cloud here with the PointSense ribbon. You can see here the point cloud. And if we have a look to the floor plan, so this is part of the floor plan from the second floor, and here are some walls, and you can see the slice through the point cloud. Here we can see the walls and the doors here and some furniture inside the rooms. And with the PointSense product, we start preparing this floor plan to get in another view to the floor plan. We call it as a prepared plan. And if you have now a look to the point cloud, you can see that's much clearer. You can see much clearer all the wall faces, the furniture, the openings. And this prepared point cloud gives us the possibility to do a very quick wall fitting. So let's start the wall fitting tool. I define my top constraint for the wall, and I start the wall fitting by just clicking 2 points inside the wall. A snapping is not necessary here. And the wall fitting starts, and in this preview window, you can see here that the system finds a wall. You can see it here in the 2 red lines. And the system also looks through all my loaded wall types in my current Revit project, and it finds a wall that fits pretty good to define its wall thickness. So the wall thickness here are 10.5 centimeters. So I come from Germany, so I use a metric system. Of course, this is also possible with imperial units, but I don't understand these imperial units, so let us use meters and centimeters for this webinar. Okay, so now we can insert this wall here, and let's do some more. Click 1 point, second point, software finds a wall, and now the software finds another wall with a thickness of 12.5 centimeters, and this has a delta of 1 centimeter to my detected thickness. What I can do now is I can say, okay, yes, I want to use this wall type, or I can change the wall type. Say I want to use a standard wall, this is a generic wall, and let us adjust this wall type to the thickness that the system finds in the point cloud. And so now it creates a new wall type with the right wall thickness. Okay. Now we create also here from the outside wall, and you can see here there are several windows, and the wall fitting tool finds also this wall here. And let's do this one again. Yes. And one more here. Okay, so if the system doesn't find the right wall face, like in this example here, you can easily click in this preview window to start the adjustment again, and now the wall fitting works well, and I can insert this object here. Okay, perfect. So what we do now is we start the aligning. So I start my Align Wall tool, select all the walls in the floor plan. You can do this also in the 3D view to select all the walls in the whole building, so over several stories. Say Finish. And now a new dialog opens where you can also see a preview here with different colors. So the different colors shows you the deviation of each wall to bring these walls in a given reference system. So let me show the reference system. Reference system means all the walls here, all the red walls here are within 90-degree angle. And if I want this, I can also bring these walls to my project north so that my whole building is well aligned to my project coordinate system. Let me do one thing before so that I can show you these angles. So I will add an annotation. So you can see here, these are not 90-degree angles. And if I do the alignment again, and let's have a look to the reference system, then you can already see here that we get this 90-degree angles. So in this list, you find all the walls. You can sort by deviation. So one of these walls has a deviation of 25 millimeters to its original position. So let me change the tolerance here to only 15 millimeters and update the process. Now you can see that the system finds another reference system. So what does it mean? We have all the red walls have an angle of 90 degrees here, and also all the blue one. And now we have a maximum deviation of 18 millimeters here for one wall. And this is good. This is a good tolerance. I want to use this the settings. And now I can also change the wall joint radius to close these open connections here. And perfect. Now I can say okay, and I get a pretty good Revit model here. What you can also say here that for these two walls, I have two walls with different wall thicknesses, but the system creates a continuous wall face here in this room. And you can see here, let me insert another annotation. You can say here that here my angle are more than 90 degrees because this wall was, or the change of this wall was not in my set tolerance of 15 millimeters, and so the software uses the original position of this wall. Okay, so let's go back to the presentation. If you have any questions about that, you can type this in this chat window, and we will answer these questions after the webinar. Let's have a look to the photo-like scan view. So I guess some of you already know the former product Virtusurf with Revit Link. So Virtusurf provides these pretty cool photo-like scan views to work with laser scan data. And Virtusurf has a link to Revit, and all the functionality of this Virtusurf with Revit Link product is now part of PointSense for Revit. So if you already worked with Virtusurf and Revit, then it's possible to use all the tools now with PointSense for Revit. And how does it work? So Virtusurf is a standalone product with a toolbar for different Revit tools, and this system sends commands and coordinates into Revit, into the PointSense for Revit add-in in Revit to create the elements directly in the Revit project. You can see this here in this short video. On the right hand side, you have Virtusurf. We start a command. In this case, it's creating a window, and you just click 2 points in the scan view, and you get the window in your Revit project. For these commands, you can use any family that is loaded into your Revit project. And of course, you can create also new types from these families with the dimensions from the point cloud. So the system will measure the width and the height of the opening and will automatically create a new type of this family with the right dimensions. Yeah, this is the beam tool, so we can insert a beam and also a column here in the middle of the room. And now we have a nice Revit project, and with some modifications with the standard Revit tools, we can adjust this beam to connect to the walls or also connect this column to the beam. Perfect. If you already know this Virtusurf commands, now we have with PointSense a very big improvement of that. Now it's also possible to use all these commands, windows, doors, columns, means together with the Revit point cloud. And for that, PointSense provides a real 3D point snap. So you just choose your family and then start picking points inside the point cloud. In the same way, you can pick points in the Virtuosurf scan view to get the 3D position of these elements. And this is possible with all the Virtuosurf tools and inside this point cloud here. All right. Yeah, let's turn off the point cloud and see the result. For the integration of the scan views, it's also possible to insert these scan labels. These are the positions of your scanners, and then it's very easy to click on this scan position and open the Virtuosurf scan view directly out of your Revit project, and then start modeling out of your Virtuosurf scan view here. And you have seen this in the video before. So just clicking points in the scan view and create nice objects here. All right. Another big fact or another key feature for PointSense is the ability to work directly inside the family editor. So as I mentioned before, Revit has no possibilities to bring point cloud data into the family editor, but with PointSense, we have 3 options. First of all, we can insert point cloud regions as a imported symbol into the family editor. For that, you can use PTS point cloud files. You can create these PTS files directly from your point cloud in the project environment. So you choose a region with a 3D section box and a 3D view and say export to PTS and then import in the family editor. You can create these PTS files with Virtuosurf or also with Recap or with Scene or with any other laser scanning software. Another option is use the Virtuosurf scan view to work directly in the family editor. So in the scan view, you can create some construction aids like model lines or construction points. And as a third option, and this is new with PointSense, you can create author images in the point cloud. You can see it here on the left-hand side. These are 2 author images of a window. And these auto images can you insert in the family editor with the right scale. So let's jump back to Revit. Let me close this project here. No. And yeah, so you can see here, this is the project environment. This is a point cloud of a building, and I already adjust my section box here a little bit. And now let me first export this part. So I adjust my section box to the region I need for my family creation. And with PointSense, I can say export point cloud. Oh, what's now? My license lost. Yeah, now it works. Okay. So we find 1.4 million points here in the section box, and we will save this as a PTS file. And in a few seconds, I will show you how to import this PTS file into the family editor. But before, I would like to show you the author image option. So I adjust a little bit this slice through my point cloud, go to the front view to see a section through this window here. And I start the author image. And while we wait for the calculation of the author image, I can a little bit explain this dialog. So we have 2 options. to create author images. You can create a colored author image, and you can also create an X-ray author image. This is what I'm doing here now. And when the calculation starts, you have here also a preview, and you can adjust the intensity a little bit to find the best way to see all the details you need in this author image. So that was a little bit too much. And you can see here, pretty cool, that you can recognize all the profiles of this window elements here. So that takes several seconds to create an auto image, depending on the number of points inside this section box. You can use this feature in the 3D view, and you can also use this feature in any planar view, and for that you have also the option to insert the resulting picture directly into your view. This is not possible in the 3D view because Revit doesn't allow using images in the 3D view, but for any other kind of view you can directly insert this. So now the image is nearly finished. All right, last percent. Okay, now we got it. So we save the file, window as a PNG, perfect. And now let's jump to the family. So I already prepared a little bit. This is a family file. If you have a look to the floor plan view, you can see here I already insert this author image from the top view into this family editor, and you can see here all the profiles. Very good. And if you go to the left, then we can also insert the author image we already created. So Windows, no, this was. So I choose here an XML file. In this XML file, there are the scale information and also the information about the picture. And here it is. And you can see here it's perfect scaled. So it's a perfect match. And then I can bring it to my family here. I think it has to be right here. Okay, so, and if you go to the 3D view, we can also insert the point cloud region. So it was this one. So I will insert not every point to and insert the center to origin to bring the middle of the point cloud into the middle of my family. So this PTS file is saved in the original coordinates of the point cloud. So then you have to adjust the point cloud a little bit to bring it to the coordinate system from your family. You can also use Vertisurf to adjust the coordinate system before you insert this point cloud. This is much easier than doing, right? I do it here. And so what you can see here, we have a perfect point cloud region in the family editor. And if you do a little bit more work, you will get something like this. And then you have a nice family that you can use in your project. All right. What we have now is a Toposurface creation. So you know that in Revit you have the Toposurface tool, and with the Toposurface tool you can define some points, and you have to define a height for each point, and this is a highly manual process. And another option is to import a list of points as an ASCII file, and so you need to create such kind of list to get the topo surface. And with PointSense, we have now the ability to pick the points for the topo surface directly in the point cloud with the 3D coordinates. So you can see this here in the video. So we have a point cloud, and we start creating some construction points using the 3D point snap from PointSense. So these construction points are some template families that we insert in the PointSense product. You can also use Virtuosurf to create these points. And if you turn off the point cloud, you can see all the points here with the 3D coordinates, and then starting Toposurface command, say finish, and we got it. We have a nice Toposurface on the point cloud. Okay, so you have seen several functions to create objects in the point cloud, walls, windows, columns, beams, a topo surface. But what is with all the other objects with all the objects that have much more complicated shapes? So for that, we can use different kinds of construction guides, model lines, construction points. We can create this in 3D directly on the point cloud. And we can also use the new workplane fitting tools to get workplanes directly on the point cloud, and also create some intersection lines from these workplanes together with other model planes. And this is something I also want to show you here in Revit. Let's close this files first, and this one. All right, and here it is. So in this example, we have a roof, point cloud of a roof. And if I turn off, you can see here, I already started modeling some lines here along all the edges of my roof. And for the last two phases, I want to show you the new tools. So I start fitting a work plane by picking several points directly in the point cloud. So I click some points on the face, on the point cloud. And you got here this information dialog with all the points. You can check the standard deviation, and if you have a point that is far away from the plane, then you can turn it off. And as a result, we get the work plane, and as well as we can create a named reference plane or some bounding model lines. And in this example, I want to like this. Turn off the point cloud. So you can see here, this is my result. These are the model lines that are now exactly on this work plane. And for the second roof phase, I will use the one-click plane. So I just need to click one point on the face here, and PointSense searches for a plane. You will also get the standard deviation, and that case I want to create a named reference plane, roof face. Perfect. So now I have here the active work plane. Okay, so let's start the intersect three plane tool. For my first plane, I will go to the list and find my reference plane for the roof face. Okay, for the second one, I want to pick one of these model lines here. Okay, and for the last one, I pick a face, so I choose this face of this floor here, and as the result, I get 3 model lines for each intersection of this 3 planes. And let me turn off this work plane here. What I can do now is with this construction, with these model lines here, I can create, for example, a mass model using this connecting points here. And you can see it here. I already prepared a mass model. I will unhide the element. So now you can see here, this is the mass model created from all these model lines. And as an example, now you can start creating a roof by face. You just have to pick the face of the mass model and say create roof, and so you get this roof element here. And you can do this with all the faces, and you can also create other objects with this method. So you can create a mass and use the mass to create slope walls, or you can also create any other element with these features. All right, let's have a look to the time. We already have some minutes left. One other thing is if you are working with point cloud, or if you are working with linked objects, you have to take care about your coordinate systems. So usually in Revit you have the project base point. This is in the middle of your project, and then you have the survey point. And if you insert a point cloud, then you have to take care about these coordinate systems. And with Revit itself, with Revit Vanilla, with standard tools, there's no ability to get a survey coordinate system out of the point cloud. So you have to set up the survey coordinate system or the shared coordinate system before you insert the point cloud, or you have to do something after modeling to pick points where are the coordinates in the survey system, something like that. With PointSense, we have now a tool that can acquire coordinates directly from the point cloud. It's very similar to the Revit tool acquire coordinates from a CAD file. So you can insert the point cloud center to center, so you can move, rotate the point cloud to your needs, and then just use this tool, acquire point cloud coordinates, and the survey point is set to the origin point of your point cloud, as well as the direction to through north. Another option to work with this shared coordinate system is setting project coordinates together with VirtuSurf. And now you have you have a Revit model, you have a shared coordinate system. You can export this model with shared coordinates. You can bring it together in Navisworks together with CAD files, point cloud files, and all in the same coordinate system. Or you can also work with CAD files together with the point cloud in the same coordinate system inside your Revit project. All right, so I'm at the end of my presentation. Hopefully I have shown you pretty good tools for PointSense for Revit. And now we have 10 minutes left, about 10 minutes left to give some answers to your questions. Okay, thank you for your attention. And now let's go to the questions.
Yeah, so we do have a few questions. I think the first one to most logically ask is what versions of Revit is the product compatible with now?
Okay, right. You can use PointSense for Revit with all Revit products, architecture, structure, MEP, as well as the full Revit from the building design suite. And you can use it with Revit 2015 and the new 2016. Some users ask me if it works with Revit LT. It will not work with Revit LT because Autodesk doesn't allow to use plugins in Revit LT.
All right. Next question here is, Does PointSense work with piping and ductwork, PointSense for Revit?
Unfortunately, at the moment, not. So I know this is a feature that many users want to see in such a product. So you should know PointSense, this is the first version of PointSense for Revit that we developed. So our first product that works inside Revit directly with the point cloud. And we have this on our to-do list, and it is a very high priority to develop piping and ducting tools. At the moment, we have not such tools. We have a pretty good solution inside AutoCAD or PointSense Plant, and for that, we also provide an export to Revit. This is still in beta status, but all customers that they would like to try this can get a copy of this installer, so you can bring pipes from PointSense Plant into Revit as intelligent models, and we will see other features directly in PointSense for Revit in the near future to create pipes and ducts.
All right. Good question here. Just something that probably bothers a lot of Revit users. Maybe you can shine some light here, Jorg. Revit 2015 and 2016 does not handle RCS files on large coordinates. You cannot snap to the point cloud. Does this affect the workflow for PointSense?
Yeah, this is really a big problem, and we are already in contact with Autodesk to solve this problem. So if you have a point cloud RCP or RCS with large coordinates means coordinate values bigger than or nearly in the 20 miles. So then you will get some problems. You can import the point cloud into Revit and it looks fine, but the point snap doesn't work. And unfortunately, the, if we ask with our software, if we ask the point cloud give us some points, then we get wrong coordinates. So at the moment, it is a problem to work with such point clouds with large coordinates, but hopefully Autodesk will solve this problem in the near future. So yes, this is the fact.
And while they're at it, hopefully they'll solve the same problem in AutoCAD.
Yes, hopefully.
So I know it drives everybody crazy.
So I guess they have no surveyors in their development team at Autodesk, so they don't know something about large coordinates or so.
I don't know. I'm sure they'll get it solved. Um, will the plane intersection tool work with curved surfaces?
No, it's a plane intersection tool.
Right.
Yeah, no. This is you need a plane, but you can use any plane surface of your model. So if you already modeled some walls, floors, or other elements, or also families, and if these objects have a plane surface, you can use this surface in this plane intersection tool, as well as levels, named reference planes, and also model lines. Each model line has a sketch plane, and this sketch plane you can also use in this intersection tool.
Mm-hmm. Okay. Just another compatibility question. They're asking, will it ever be available for Revit 2014? And I think the answer is no, due to some limitations, right?
Yes, that's right. Now it will not be available for 2014 because we use some techniques from the API that were new to 2015, and so it will be not possible to create all these features in 2014 or in other older version.
Okay. How does PointSense handle sweeps like moldings around windows as families are built up? What if there is a relief above the window? What do you just? It's more detailed design question, I guess, but
Yeah. you can, what is a good workflow is creating this X-ray author images. So you can start with a section through the point cloud where you can see the profile for your sweep or whatever you want to model. And then if you have a look to the point cloud inside Revit, then it's often not very clear to recognize the profile. And in that cases, you can create an author image, an X-ray author image, and in this author image, you can much better see the sections through the point clouds, the profile, and use that author image to create your profile for any modeling element. You can also use the Vertisurf scan view to pick the points exactly on the surface, or you could do it with the author image.
Yeah.
So you can for in-place families, or also to bring the author image into the family editor. It's also possible with 2D families. So you can also insert this author image in a 2D profile family to create the profile using in any other object later.
Okay. So a question, when you were using the wall alignment tool, you showed restricting the angles to 90 degrees. Some people want to keep the as-built. Is it still possible to link the walls up while keeping closer to the as-built situation?
Of course it is. In this alignment tool, you can set up an increment angle for the reference system. So the standard is 90 degree. So you can change this angle to 45 degree or even to 180 degree. So, and if you change this increment angle, then you will be closer to your as-built situation, and you can also change your tolerance values for the allowed deviation and to find the best way to be close to the point cloud, but to align the model a little bit to your design constraints. So this is a really powerful tool, and you have so many possibilities to adjust your tolerances. You can also choose walls to define your reference system. So for example, if you already have a Revit model and you want to create a new part of the project in the point cloud, then you can already choose a given wall from your existing model to define the reference system for all the new walls. It's also possible. And all is in the tolerances the user has given to the system.
Cool. I'm getting some questions about, pricing and how licensing works, so I'll go ahead and answer those. For those of you wondering if the product's available now, yes, it is. We launched it at the beginning of May. We're just now having the webinar. If you're interested in a trial, they're 15 days. You can go to the website. You can either go to FARO3dsoftware.com, FARO-3d-software.com, or you can go to the old Qubit website, qubitusa.com. It all takes you to the same place, and you just click on the contact form to request a trial on the left side of the panel. Fill out the form, and the representative in your area will contact you and get you set up. As far as cost, it of course varies based on where you are regionally. In the U.S., for example, it's somewhere around $3,800, but that price can vary based on exchange rates and all that good stuff. So as far as licensing, it works just like all other Qubit licensing. So if you're not familiar, it is standalone or network options. The standalone is a USB dongle. It's plug and play, meaning that you can install the software to as many machines as you want, but you need the dongle in the machine to make the functions work. If you have a network option, the network dongle resides in the server machine and can distribute the number of seats owned by the customer to all the client machines or whoever has access to that server. So hope that gives you all an idea of licensing, pricing, and trial information from the website. Let's see if there's any more questions here. I know there's some more detailed questions that we may answer afterward, a little bit more in depth. We have some people asking us to do certain projects. Can you do an MEP project using the Freestyle handheld in a process plant environment soon? Sure. I could do it in PointSense plant now, but as we stated, it's not ready for PointSense for Revit yet. And then, of course, we're getting pressure here. Jorg, any projected date for the piping side?
Yes, I know it.
It's next week, right? It's next week?
No.
Okay, next week sounds good.
Month. No. So we will hard work on that. Trust me. So.
Okay.
I know you will give me more pressure on that.
Everyone listening, send in your emails. I will direct them to Jorg. All right, so let me make sure I answered majority of the questions here. I think we're pretty good. Are there any more questions on some of the functionality you saw today that you're not sure how it works? Or okay, I'm just looking through once more. Here we go. When switching between the family editor and the Revit model, is it necessary to use the linking point cloud coordinates tool again?
The linking, yeah, I think you mean the Virtusurf link to the point cloud.
I think that
right?
came from an advanced user.
Okay, so maybe there's a difference between the point cloud and the project and the point cloud and the family editor. So the point cloud and the project is of course is an RCS or an RCP file, so that is linked to the project, and the path for the point cloud is saved in the project, of course. And in the family editor, this is imported as an import symbol. So this is a part of the family. So usually if you are ready with your modeling of your family, you should delete this point cloud region out of your family, because otherwise the family file is much bigger than you need it. And so it is a difference. So it's not a linked point cloud in the family editor, it's an imported CAD symbol with points.
Okay. Last thing I want to mention, there, of course, there's a lot of piping comments. So we mentioned PointSense Plant. There is a little beta, if you all are interested, that will allow you to import your Revit pipes from AutoCAD that you extract in PointSense Plant to Revit with intelligence. So it is a beta tool that we offer to PointSense Plant users that want to bring in, pipe levels, tees, reducers, so you can certainly use that, and structure will also come in with intelligence from the PointSense Plant product. Okay, another question here. Is Virtusurf included in the price? Yes, the Virtusurf connection to Revit would be included in the price for PointSense for Revit. So it's all one package. PointSense for Revit includes the full ribbon that you saw sitting inside of Revit for PointSense, as well as the Virtusurf interface to Revit. All right, folks, I don't think I see any more questions. If I see any that are left open, we'll be sure to contact you all directly. We have the list here. And thank you all for sitting in. Hope you give it a shot. Remember to go to the website and request a trial. And otherwise, this recording will go out probably in the next day or two. And again, thanks for your time.
Okay.
Have a nice finish to the week. Bye-bye.
Bye-bye, everyone. Bye.